All right, today's notes are on function notation. Function notation is basically used with an f of x instead of a y, and it's made so that way we can represent many functions at the same time, and we know exactly which one we're talking about. It also is helpful because when you use function notation, you're going to be able to know exactly what your x is and what your y is, both at the same time. So when we use this f of x, we're just saying it's the function named f, and inside here is what your x value is. Whatever number you end up with at the end, or your output, we call that the y value. All right, so it tells you both your inputs and your outputs. Remember that it's read f of x instead of f parentheses x, and just understand that that's your y value. So let's go ahead and jump into some of these equations. It says evaluating functions using function notation. I have f of x is equal to 7x minus 1, and I want to find f of negative 2. Now remember here, it's supposed to say f of x, but where the x normally is, they're putting a negative 2. So what does that mean? That means in this case, they're telling me the x value. Let me go ahead and highlight it so you can see. Where the x should be, they're putting a negative 2. What they're telling you is wherever you see this x, you're going to replace those x's with negative 2. So instead of writing f of x, they're telling me that x is negative 2. So I'm going to write f of negative 2. That's just saying this is what happens when I plug in negative 2 inside my function. What I get is 7 times, there's that x again. I'm going to replace it with the negative 2 minus 1. So f of negative 2, that does not mean multiply. It just means when I plug in negative 2 into my function, what I end up with is 7 times negative 2 is negative 14 minus 1. F of negative 2 equals negative 14 minus 1 is negative 15. How are you supposed to read this? Well, again, f of negative 2 means when your x value is negative 2, your y value ended up being negative 15. So it gives you a bunch of information all at the same time. When you plugged in, when x is negative 2, and you plug it into your f function, then y is negative 15. That's exactly what it's telling you. Okay, it gives you a bunch of information right away. All right, let's try it again. We're going to do the exact same thing this time. They say g of x is equal to x squared minus 4. I want to find g of negative 5. That's saying my x value is negative 5, because that's where the negative 5 is where the x should be. Then that's telling me to go back, and anywhere I see an x, I'm going to go ahead and replace it with the negative 5. So I see an x here, and I see an x here. Let me go ahead and start replacing it. That's g of negative 5 is equal to negative 5. I'm going to put that in parentheses. Squared minus 4. G of negative 5. When I plug in negative 5 into my g function, negative 5 squared, that's negative 5 times negative 5, which is a positive 25 minus 4. And I get g of negative 5 is equal to 21. What that's telling me is that when x is negative 5, then y is 21. All right, these next two examples are going to be a little bit different because this time they're say given h of x is equal to 5x minus 1, find x if h of x equals 9. First of all, they're telling you to find x, so you know you don't have it. Second of all, they did not replace the x. Instead, they wrote h of x, which remember, this really means your y is 9. So I'm going to write this whole thing is y is 9. They're telling you that the answer is 9. So anywhere I see an h of x, I get to replace all of it with the number 9. Well, here's an h of x. They told me h of x is 9. So I get to replace that number with the number 9 is equal to 5x minus 1. And from here, we're going to go ahead and solve. Divide both sides by 5. And I get x equals 2. Again, what are they telling you? They're telling you that when x is 2, that's what we just got, then my y value is 9. It's kind of the same thing, but going backwards. When x is 2, y is 9. Okay, we're going to do the next one really quick. Given f of x is equal to negative x plus 2, find x if f of x is equal to 6. So in this case, they told me that f of x which really is just your y, is 6. So anywhere I see an f of x, I get to replace it with the number 6. I see an f of x right here. All of it gets replaced with the number 6 is equal to negative x plus 2. I'm going to subtract 2 on both sides. I get 4 is equal to negative x. That's not done, it's close, but to get rid of that negative in the front, I need to divide both sides by a negative 1. Those negatives are going to cancel, and I'm left with x equals negative 4. What is that telling me? That's telling me when x is negative 4, then y is 6. And that takes care of the front side of the notes. Let's go ahead and go over to the back side. We're going to practice really quick just because we're going to try to make this video a little bit shorter for you if we can. So I'm going to move a little bit faster. Here we go. I want to find f of x equal to x squared. And, well, I'm sorry, they give me a bunch of functions here. And I'm trying to evaluate them. So here, remember I said one of the biggest advantages is I'm going to take g and plug in 10 into my function g. Well, this is my function f. I don't want to use that one. I want to use this one. That's why it's so important to know what these functions are, because it lets you know you can deal with many functions at the same time. Now, as far as that 10 is where the x should go. So I'm going to replace that 10. Anywhere I see an x, I get to replace it with 10. So I write g of x is equal to negative 3 times, there's an x, I'm going to replace it with the number 10 plus 1. Notice that I'm replacing the x because that was an x value right here. All right, what do I get? I get g of 10 is equal to negative 30 plus 1. G of 10 is equal to negative 29. And again, that tells you when x is 10, then your y value is negative 29. Again, here they give you another x value. That's where the x is supposed to be. And I'm going to plug it into my f function. That means wherever I see an x in my f function, I'm going to replace that x with the number 3. So I get to write f of 3 equals parentheses 3 squared plus 7. F of 3 is equal to 3 squared is 9 plus 7. F of 3 is equal to 16. That says when you plug in a 3 into your f function, the answer you get, or your y value, is going to be 16. All right, and then on this one, I want to plug in h of negative 2. That means I'm going to plug negative 2 into that's an x value right there. I'm going to plug negative 2 wherever I see an x into my h function, which means I need to write a negative 2 on the bottom. Hey, I'm going to do a shortcut. 12 divided by negative 2, that's negative 6. Sometimes you'll see mathematicians, they'll write it once here, and then they'll just keep leaving it blank here because they assume you know that's h of negative 2 is equal to negative 6. Okay, you'll see me do it on the next one. Okay, I got find x if g of x is equal to 16. This time they're telling me all of g of x. All of g of x is 16. They didn't tell me x was 16. They told me g of x was 16. That means they're telling me a y value this time. So this is a y is equal to 16. So anywhere I see the g of x, I get to replace it with the number 16. I see a g of x here. That needs a 16 in its place. Not inside. It's the whole thing becomes 16. So I'm going to write 16 equals negative 3x plus 1. Subtract 1 on both sides. 15 is equal to negative 3x. Divide both sides by negative 3. And I get x is equal to negative 5. What that says is when you plug in negative 5 into your g function, the answer you get, or your y value, is 16. All right, let's try the next one. Again, they're telling me h of x is equal to negative 2. That's all of h of x is equal to negative 2, not just the inside part. So anywhere I see an h of x, I get to replace it with the number negative 2. Here's the h of x. That's going to get replaced with the negative 2. So I end up with negative 2 is equal to 12 divided by negative 2. I'm sorry. Nope. Sorry. Only the h of x is a negative 2. On the bottom, It's just an x. I can't get rid of that. Okay, this one's going to be kind of tricky because when you have an x on the bottom, the way you get rid of an x on the bottom is by multiplying both sides by that variable. So I'm going to multiply both sides by x, and all that's going to allow me to do is cancel those two. So I still have a 12 on the right, but x times negative 2 is negative 2x. And unfortunately, you still have an x, so I'm going to divide both sides by negative 2. So that way I can isolate the x, and I end up with x is negative 6. Kind of a tricky one because it's hard to get rid of that x in the bottom. You just have to remember to multiply both sides by the denominator in this case. All right, and then last one, find x if f of x is equal to 23. Here's f of x, so this gets replaced with the number 23. Notice that the x is going to stay the same because I'm replacing all of f of x, only the places where it says f of x. So f of x is equal to 23. So I write 23 is equal to x squared plus 7. I'm going to subtract 7 on both sides. I get 16 is equal to x squared. The opposite of squaring something is square rooting something, so I'm going to square root both sides. And there's a rule that says when you put in a square root, you need to put in a plus or minus. So my answer is positive and negative 4. And if you don't remember that rule, we're going to go over it a little bit more in depth as the year goes on. All right, so that's great if you have equations. We're going to show you what happens when we have graphs. It's pretty much the same thing. It's just you have to interpret what you're reading as a graph. All right, so here they say what is g of 0? Remember, this is telling you that inside is an x value of 0. And here's your g function. So they're telling you x is 0. Well, when x is 0, here are your x's. When x is 0, your graph is at 3. So I know that when you plug in 0, the y value is going to be 3. Let's try that again. Here they're telling you what's g of 4. Well, when they tell you g of 4, that means your x value is 4. Well, here's my x values, and here's the x value of 4, and I'm going to go up until I hit the graph. G of 4 must be 6. All right, next one. What is g of 6? Again, they're telling you the x value is 6, so I'm going to go over to the x value of 6. Here is my x value of 6, and when I go up, I get 1. Okay, here's a tougher one. Can you find the x values for when g of x is equal to 3? Notice that this time they did not tell you the x values. They gave you the g of x. And if you remember, g of x is the same thing as y. So they're asking you, when does y equal 3? Well, here are your y's, and here's the 3. So they're asking what x values gives you the 3? Well, it happens at 1. It happens at 2. It doesn't happen at 3. It doesn't happen at 4. It happens kind of like at 4 point something, but I don't know what that is, so I'm just going to skip it. Oh, and it happens again here at 9. So it looks like it happens at 1, 2, 9, and then some decimal, which I'm not going to worry about, but you really should be writing that extra decimal. But for right now, we're just going to give you examples of 1, 2, and 9. Ooh, it also happens at 0. I totally forgot. It happens right away in your graph here at 0. Okay, same kind of question. This time they're telling you when is f of x equal to 6. Again, notice they didn't tell you, they didn't give you an x. They gave you an f of x. An f of x is a y value. They're asking you when is y equal to 6. Here are your y's, and here's 6. So when does y equal 6? Well, it happened right there. That's when x is 4. And it looks like it doesn't happen again. So this happens when x is 4. When does f of x equal to 0? Again, this is a y value. When does f of x equal 0? Well, when does your y equal 0? Here are your y's. Here's 0. When is it touching 0? It's touching right here at 7. And it doesn't do it again. So when x is 7. What is the domain of the function and what is the range of the function? Domain means how far to the left and to the right does it go? Domain is your x values, your inputs. So how far to the left and to the right does it go? So the furthest to the left that my graph goes is right here at 0. And the furthest to the right my graph goes is right here at 12. And notice that 0 and 12 are part of your graph. So we're going to write the interval from 0 to 12. And because it was on my graph, I'm going to put brackets on them. What is the range? Range means your y values or your outputs. So how far down and how far high does your graph go? Well, the lowest your graph goes is right here at 0. And the highest my graph goes is right here at 6. It doesn't get up to 7 because there's no part of the graph that reaches a high. So the lowest was 0 all the way up to 6. And it does reach those numbers, so I'm going to put brackets on both of them, 0 to 6. Okay, you should pause the video and try these out yourself. I'm just going to assume you did that, and I'm just going to go through the answers really quickly. It says use the graph y equal to f of x. Oh, I'm sorry, I forgot to mention over here we weren't trying to use f of x. I misplaced this. It should have been g of x because f of x is the graph on the below. So I'm sorry if I confuse you because we were talking about the g function over here. All right, use the graph of y equal to f of x at the right to answer each question. I want to find f of 4. Now here, that 4 is in the place of the x, so they're telling you when x is 4. And let me go ahead and put some numbers here just to make it easier on me. This is going to be 2, 4, 6, 8, and finishes at 10. 2, 4, 6, 8, finishes at 10. All right, when x is 4, here are your x's. And when it's 4, that's right here. What's my y value? My y value is 0 when x is 4. Again, here they gave you an x. They said when x is 6. What's happening when x is 6? Well, here are your x values. I really should put x's and y's here. When x is 6 is right here. Where does it touch my graph? Right here. And what's that y value? 4. This time they say, for what x values does f of x equals 2? Notice that there is no value for x. They gave you an f of x instead. Remember that an f of x is just a y. So they're telling you what happens when y is equal to 2. Here's your y's, and I want my y to equal 2. That's here. When does y equal 2? Well, that actually happens twice. It happens here at 2, and it happens here at 5. So you get two answers here. You're going to say when x is 2 or 5. Both of those work. All right. Almost done. We got a couple more questions. For what x values does f of x equal 1? Again, they gave you an f of x. F of x is the same thing as a y value. When does y equal to 1? Here's your y equal to 1. It happens at 0.5, at 3, and at 4.5. So we're going to write all three of those answers. It happens at 0.5. Oops, I wrote 0, 5. That's a mistake. 0.5 at 3 and at 4.5. How many x values makes the statement f of x equal to 0.5 true? Again, they gave you an f of x. An f of x is a y value. How many times, not when, but how many times does your y value equal 0.5? Well, here's 0.5. And it happens right away here. That's once. Here's it touching at 0.5 again. That's twice. Here's it touching at 0.5. That's 3 times. So it looks like it happens 3 times. They're not asking you where it happens. They're asking you how many times does it happen. All right, and we're finally down to the last question. What's the domain and the range of the graph? Domain means how far to the left and how far to the right does the graph go. I would probably assume that's a -1 right here. So as far as to the left, it looks like it goes as far to the left as -1. As far to the right, a common mistake is for students to say it goes all the way to 10. But look, your graph didn't go all the way to 10. Your graph stopped at 8. So it went as far left as -1 and as far right as 8. I'm going to write from -1 to 8 for my domain. And then the range is how far high and how low did it go? So you start for how low. What's the lowest your graph went? Well, it looks like it went to 0. It didn't go down here to the negatives. So it went all the way down to 0. And what's the highest it went to? Same thing. It looks like it only went as high as 8. There's no place on your graph where it reached 9. So this is going to be as low as 0 and as high as 8. That's the lowest, that's the highest. So I'm going to write from 0 to 8. All right, that's all the notes we have for today. As always, if you have any questions, feel free to ask.